Today, we're going to crack a secret code. It's hidden everywhere, right in plain sight, and it's the key to so much of the beauty we see in the world, from the wings of a butterfly to the design of a building. We're talking about symmetry.
So, to get started, just take a look at these next few images. And as you do, ask yourself, what is the one thing they all share? What's the hidden thread that connects all of them? First up, a beautiful butterfly. I mean, look at it. But try to look past the colors for just a second and focus on the shape. You see how the left wing is a perfect mirror image of the right? It creates this balance that's just so satisfying to look at.
Okay, next, a flower. Each one of its petals is a perfect copy, and they're all arranged around that single point in the middle. It doesn't matter how you turn it, the shape basically stays the same. That repetition, it just feels right, doesn't it? So harmonious.
And finally, check out this amazing rangoli. See how that pattern of red petals just repeats itself as you move around the design? Each part comes back to itself after a turn. It's that very repetition that makes it so visually stunning. So, what is the hidden thread? What's the secret? It's a pattern, and it's called symmetry. It's this idea of repeating parts in a way that's definite and predictable. And it turns out our brains are just wired to find that kind of order beautiful. So let's break down its two secret codes. We're going to start with the type of symmetry that's probably the most intuitive, the kind you've been playing with since you were a kid. It is all about one simple idea, a perfect fold. This is what we call a line of symmetry. Just imagine a line that cuts right through a shape, splitting it into two pieces. Now, if you could fold the shape along that line and the two halves match up perfectly, you found it. We call those matching pieces mirror halves. Let's try a really simple folding test. Take this triangle with the dotted line down the middle. If we fold it right along that line, one half lands exactly on top of the other. It's a perfect overlap. Those are our mirror halves, and that dotted line is our line of symmetry. Simple, right?
But here's where it gets interesting. Not all lines work, even on similar shapes. Let's compare a square and a rectangle. If you fold a square along its diagonal, you get two perfect overlapping halves. But try that with a rectangle, the corners just don't line up. It's a fantastic example of how, even though they both have some symmetry, they aren't the same. The square has diagonal symmetry, but the rectangle doesn't. You can even create your own symmetrical figures using this exact principle. I bet you've done this before, right? You take a piece of paper, fold it, drop some ink on one side, press them together, and when you open it back up, bam! You got a perfectly symmetrical ink blot devil where that fold line is the line of symmetry.
Okay, but what about shapes that feel balanced, that feel orderly, but have no perfect fold? For those, we need to decode the second secret code, the perfect turn.
Think about something like a pinwheel or maybe the blades on a fan. It feels symmetrical, right? But if you tried to fold it in half, the pieces just wouldn't match up, so it can't have a line of symmetry. So what on earth is its secret?
Well, its secret is rotational symmetry. This happens when you can turn, or rotate, a figure around a fixed center point, and it looks exactly the same as when it started, even before you've done a full 360-degree spin.
For a square, that magic number is 90 degrees. You give it a quarter turn around its center, and it lands perfectly on its own outline. This is its smallest angle of symmetry.
And since a 90-degree turn works, it's going to look the same again at 180 degrees, then 270, and finally back at 360. That gives it 4 positions where it looks identical within one full rotation. We call this number its order of symmetry.
And here's the really cool part. There's a beautifully simple rule for this. For a shape with repeating arms, like a star or a fan, you just divide 360 degrees by the number of arms. So, a 3-armed figure, its first angle of symmetry is at 120 degrees. A 5-armed figure, its first angle is at 72 degrees. It's this elegant, predictable, mathematical pattern. So there you have it, our 2 secret codes, the perfect fold of line symmetry and the perfect turn of rotational symmetry. And once you know what to look for, you start seeing them everywhere. And often, you'll find both in the very same object.
This all leads us to the most symmetrical shape of all, The circle. I mean, it's kind of achieved perfect symmetry. You can rotate it by any angle, and it always looks the same. And every single diameter is a line of symmetry. It has infinite symmetry of both kinds. It's amazing. Now for a real-world example that combines both, just look at the Ashoka Chakra from the flag of India. This thing is an absolute masterclass in symmetry. It has an incredible 24 lines of symmetry and an order of 24 rotational symmetry. And this stuff isn't just for ancient symbols. The outer boundary of India's new parliament building is this massive modern structure, and it's designed with 3 lines of reflection symmetry and an order 3 rotational symmetry. It's just a timeless, fundamental principle of great design. So, symmetry isn't just some abstract math concept. It's a blueprint for beauty, for order, and it's hardwired into nature, into art, into architecture. Now that you know the secret code, now that you can see the pattern, the only question left is, where are you going to find it next?